Welcome at Ask the Professor. I really enjoyed the questions from welding to noise and all kinds of things, and also some theoretical Hertzian contacts. Great to see, and also nice to know that you really are enthusiastic to know more in depth how it works. So keep this spirit alive, put everything on the forum, and let's go for the questions for now. First question is about weld tempering. Why is it new? Is it a new technique, or is it old school, and why? Mostly it's because of getting rid of wear or control wear with special material you weld on top of the rail or on the gauge corner. But that's only on grooved rail. And the question is why, you could say, why, and that's the question of today, why not in heavy rail? And that's a simple answer, because we already tried in heavy rail, and then it's like a tin can where you try to open it, it's because just cycling and rolling up on a full bale, you could say. But it's not attached to the basic material. It will just go off. That's really a problem. You cannot fix that with welding, and that's because of the heavy rail and the heavy load, you could say. So for heavy rail, you can just forget it. You need other techniques than welding. Of course you can use it when it is not mostly used heavily per day, for example in the harbors or to put trains on, but then on the other side you don't have wear. So that's why you don't see it in heavy rail. Another question is about when we have high-speed switches, like higher speed and more than 300 kilometers an hour, what are the extra conditions or extra constraints for the switch or the switch design? And that's not that simple, but also simple in a way when you only look at energy. How much energy you put in this switch, in this high-speed switch, when you have small bumps or not a good alignment, for example, or the geometry is not right. And of course, it's always not right because you have a frog, you have open spaces, because the wheel has to jump from one rail leg to another one. That's because it is a switch. So that would be really exciting and also challenging to fix that with a high speed. Therefore, my suggestion should be, why not make a different design? So you could, for example, run on the flange. Then you're also not jumping from one leg to another in this nobody's area where there is no metal. But then you are just running on your flange and then take the gap to the other side. But that's tricky, because when you look at the TSIs, the normals, the size, you would say, the height of this flange is not defined. So you have different height of this flange, and then you have really a problem, and you could have derailments at the end. And that's why we don't use this technique in heavy rail. You see this on rail like tram and metro systems. So that's it. So I think we have to change some regulations before we can do this special trick, just running the extra of the wheel like the flange. When you calculate Hertzian contact stresses, for example, when you have a wheel-rail contact, that's about this coin, you could say, of a €2 coin. That's the size. And then you can imagine that all this load, say 21 or maybe 30 tons of axle load, is just pushing on this steel. So there's a high pressure, and that's why you can calculate that with Hertzian contact formulations. But when you go for a curve or a two-point contact, then Hertzian is not allowed, it's not valid anymore. Then you have to switch to Kalkar techniques, and that's really complicated. That's maybe too far for now, but you have to keep in mind that Hertzian contact is just good for a first guess, or when you are driving straight with one-point contact. But you're right, when you have also contact with, for example, the bearings or the balls of inside the bearings, you can also use these Hertzian contact techniques, and also other contacts inside, like joints or whatever. So, of course, yes, with Hertzian you can calculate all these stresses inside the construction, and then you will see that the biggest constraint or the biggest problem and the highest stresses you will only find with wheel and rail contact. So be my guest and calculate how the other stresses are developing inside the construction. Go for it. A nice question about noise and how can you get rid of this noise. But you have two families of noise, you could say. One is when you have squeal noise, when you go through a curve or a switch. That's because flange is in contact with the rail, and when there is no lubrication in between, you have a really itching pain in your ears. That's what you hear, for example, when you're on the station or somewhere in the city when the train is going through a curve. Then the solution should be make it easier, lubricate the contact, and then you have a lot of reduction of this noise. And that's more convenient for everybody, I think. Another one, when you say, okay, I like to get rid of noise because of rolling, that's what you see, for example, when you just go on a straight track, or you could say the tram in general when it is driving on a track. And then you need these rail dampers or other things to damp out all these special high forces, and it makes this squeal noise or this noise of this rolling. You can reduce this, rail dampers, but also you can fix a lot of other things, damping other materials, or the foundation you can also put on springs or whatever to damp out all this energy of vibrations. So what do you like? And that's really the question. When you really like to say, okay, I make it easy going and I like to get rid of a lot of problems in wheel-rail interface, then lubrication or friction management on top of rail should be a solution. So try it. Many thanks for all these questions of today. I really enjoyed. Hopefully you get some information you can go on, and maybe also challenging each other for next questions or cases. Please upload your ideas on the forum, and see you next time in this Ask a Professor video. Keep on track.